I tried running a ChatGPT style AI model locally on a Raspberry Pi, and the results were not what I expected. When you use an online or cloud-based service like ChatGPT, you're obviously sharing your data with another company, which might be okay in some cases, but there are a lot of instances when you might not want to do this. So running a model locally is a way to still make use of the features or benefits of something like ChatGPT, but keeping it all local. So no private or sensitive information is shared with another party. This brings up the question of what hardware you can run it on, which led me to trying out a few models on a Raspberry Pi. Now a Raspberry Pi is obviously not going to be able to run models like a high-end PC with the latest GPU, but it actually performed a bit better than I expected, and there are some accessories like the AI accelerator hat that I tried out too. For comparison, I also ran the same model on an N100 based Mini PC that comes in at a similar price to the Pi 5 setup. So I'm going to be running the test on 3 different hardware configurations. First up, a 16GB Pi 5 by itself, then a Pi 5 running the Hailo AI HAT Plus 2 accelerator, and finally an N100 based Mini PC. To keep this fair, I'm running the same Qwen 2.5 1.5B language model on each setup, and I'm pulling the timing stats directly from Ollama's API, so we can get the actual tokens per second rather than guessing it from how fast the text appears on a screen. I chose this particular model since it's the most complex model that'll reliably run on all 3 sets of hardware. I'm going to run a series of 3 prompts on each, and for the performance testing phase, I'll run each test 3 times as well. These are the prompts I'm going to be using. First up, we'll ask it to explain how DNS works in 200 words. Then we'll give it a physics question, asking about a ball traveling up from the ground at 14 meters per second. And lastly, we'll ask it to write a 120-word intro for a blog post. For the performance test, the main metrics we're interested in are the tokens generated per second, and then the total generation time for a fixed number of tokens. This gives us an indication of the initial processing time, often called the time to first token. So let's start out with the Pi 5 setup. You'll notice that I have a USB connected mSATA drive connected to the Pi as the boot drive, and that's because I wanted to keep the PCIe port free to also try add the AI HAT Plus 2 accelerator to see how that boosts performance. I don't want the Pi running off a slower microSD card, which may affect the model loading and startup times. I'm running Pi OS Trixie on it, and I've installed Ollama and downloaded the Qwen 2.5 model. To kind of prime the system before I run the actual prompts, I always start by sending the simple prompt hello. Then we can start with our 3 prompts. I'll show you the first couple of seconds for each prompt so that you can get a feel for the speed that it runs, but I won't wait for the whole prompt or go through all of the details of each prompt in this video. I'll put all of the responses in my blog post linked in the video description. First up is the DNS prompt. I was actually pleasantly surprised by how quick the Pi ran this. This is playing back in real time, and we get about 11 tokens per second. You can also see all 4 of the Pi's CPU cores are running at 100%, and the active cooler is spinning up too. So you can't do anything else on the Pi while the response is being generated, and that's important to consider for the Hailo test. The Pi's response is quite good. It got the correct inclusions that I asked for, and it's accurately written. It's a little bit simplified, but I'd say it's still quite clear. Next up is the physics question. This question requires the model to interpret what is being asked, then choose and apply the correct equations, and then work them out correctly. This one's quite easy to assess. It's got all 3 answers correct, it's used the correct equations and reasoning, and it's clean and well structured. Lastly, we've got the blog intro. This assessment's again quite subjective, but I'd say it's quite good. It reads a bit like a description rather than an intro, but it mentions privacy, speed and cost, and it's also clearly written. I then ran the performance test script, which runs the same 3 prompts 3 times each and controls the model and prompts a bit better to give us some performance data to analyze. I'll graph this and show you at the end. Next up is to add the AI accelerator to the Pi. Raspberry Pi have the original AI kit based on the Hailo AI accelerator, which adds up to 13 TOPS to the Pi. Unfortunately, this hat doesn't have any RAM on it, and it's designed around image processing, so it can't be used to run LLMs. That brings us to the HAT Plus 2. This one's based on the Hailo 10H accelerator, which can do up to 40 TOPS. But more importantly, it's got 8 gigs of onboard RAM, which allows it to run generative AI models, or LLMs. The implementation of the software side is a bit more complex than just running Ollama, but they've got some pre-configured models to choose from. one of these being Qwen 2.5 Instruct 1.5b, which is one of the reasons why I chose it for testing. The difference in software means that it's presented slightly differently in the terminal. The whole response is provided after it's been generated, but you can see now while the prompt's being generated that there's no load on the Pi CPU cores, so the Pi is completely free to work on or to manage other tasks. We'll go through the numbers a bit later, but the hat was noticeably slower in producing the responses, which honestly wasn't what I expected. The accelerator is supposed to make this faster. And it didn't end there. The quality of the responses was also quite poor. The DNS explanation had inaccurate information, terminology issues, and missed explaining resolver flow. The physics reasoning prompt got the wrong return time, didn't provide the total time, and in general had weak explanations and incomplete reasoning. And lastly, the blog intro mentions the required themes, but the structure is very basic and it lacks engagement or thought. I thought maybe the model was just a bit weak, although it should be very similar to the one being run on the Pi 5 only. So I then tried running one of its DeepSeek models. But that didn't help either. The DNS explanation was worse, it didn't produce a usable answer, and it mainly just outputted thinking text. It calculated the incorrect height for the physics question, and that led to the wrong time being calculated too. It again showed confused reasoning and thinking out loud. The blog intro contains incorrect technical claims, isn't aligned with the prompt intent, and just felt hallucinated and unreliable. At this point, I started questioning whether the accelerator was actually designed for this kind of workload at all. After all, the models that I've tried running on it are the ones specifically configured for this hat. So all up, not a great result for the AI HAT Plus 2. But I still ran the 3-test script using the Qwen model anyway, so we got something to compare performance with the other options. Next, let's move on to the N100 PC. This has a faster processor than the Pi 5, so on paper it should produce faster results. At $210, it also costs about the same as the base Pi 5 setup. The 16GB Pi 5 power supply, active cooler, M-SATA drive and storage hat comes to a combined $205. And that's going off the list price of the Pi 5, which is often difficult to get. This PC comes ready to run, you just need to plug it in. I've installed Ubuntu 25.10 on it, so we can run the same Olama version and same Qwen model that we ran on the Pi 5. After our hello prime, we can give it the DNS prompt. That's running really well. It looks like it's quite a bit faster than the bare Pi 5 was. The completed DNS explanation is very good. It's got all the correct inclusions, it's well structured, and it's easy to follow. There are a couple of minor wording inefficiencies, but that's mainly due to the small model being run. I had high hopes for the physics reasoning, but it let me down. It got the correct time to the top and maximum height, but it calculated the incorrect total time. The working out and equations are correct, but it came to the wrong conclusions. Because it was close, I ran it a second time, and it then gave me all 3 correct answers. The blog intro was about the same as on the bare Pi 5. It's good, it mentions the key themes, it's clear and readable, but it is slightly generic and it's not very engaging. So the overall quality of the responses from the bare Pi 5 and the N100 PC are quite good. They're obviously nowhere near the level of modern cloud-based models, but they're very usable for light tasks running locally. I was quite disappointed that the accelerator performs worse than the Pi itself, albeit that the Pi was free to do other things while the accelerator worked on the prompts. For LLM specifically, I wouldn't recommend the Hailo Hat, especially given its $130 price tag. It's clearly been designed more for vision and edge AI workloads and not general language models. As for the performance tests, in terms of raw tokens per second output, the N100 PC is the clear winner. It was over 1.5 times faster than the bare Pi 5 and almost 3 times faster than the Hailo accelerator. Running the DeepSeek model on the Hailo accelerator only results in about a 2% improvement. Moving on to the total time, the results were quite similar again. The N100 is the fastest by quite a significant margin, and the Hailo accelerator takes more than double the N100's time. Interestingly, the total time across the board was significantly faster for the blog intro, and given that the tokens per second were similar to other prompts, this indicates that models spent significantly longer before generating the first tokens for the DNS and physics responses. That's probably because the blog intro prompt is quite open-ended, where the DNS prompt asks for specific inclusions and the physics one has to be numerically accurate and use the correct equations. Lastly, looking at power consumption, the Pi 5 only uses 11 watts under full generation load. The Pi 5 and accelerator use 7 watts and the N100 PC uses a much higher 30 watts. Adjusted for the speed that each device produces the output, we can calculate the energy consumed per token. Unsurprisingly, the N100 PC is the least efficient, using the most energy per token. But because of the Hailo accelerator's speed, the Pi 5 only setup comes in slightly better even though its power draw is higher. So is running your own LLM locally really worth it? Well, to figure that out, we need something to compare it to. So I found a comparatively low-level cloud-based model that was available through a paid API. For the comparison, we're going to run the same Qwen 2.5 model, but the smaller size model that they have available is their 7 billion parameter one. I put the same 3 prompts and test script through the cloud-based model, and these were the results. The DNS explanation was a lot better structured and gave the best balance between simplicity and correctness. The physics reasoning responses were also correct, and they were clearly explained without providing much fluff. And lastly, the blog post had the right inclusions and was also well structured. Performance was also significantly better. The OpenRouter model dwarfs the other results in tokens per second, and also ran faster in terms of total time too, although this was a little bit more comparable. Perhaps most interestingly is the cost. So after my hello, 3 test prompts and then 9 performance test prompts, the total cost for all of these tests was just 0.06 cents, or 0.06 of a cent. I could run a similar prompt every 3 minutes for about 2 years, before I'd spend the same as the hardware cost of the Pi setup, and that's before electricity costs. So really I think the answer comes down to privacy, and maybe whether or not you have internet access. If you're handling sensitive information, or don't want to share private data with another company, or if you're deploying the model in a location that doesn't have a reliable internet connection, then it makes sense to run a model locally. But if not, it's probably going to be better value to make use of a cloud-based service. You also have the added benefit of being able to run more powerful models for certain tasks and cheaper models for less intensive ones. Let me know what hardware you've tried running local LLMs on and what your experience has been with them, or if there's anything else you'd like to see me try run on them. Thanks for watching. Please remember to like this video if you enjoyed it, and subscribe for more tech and electronics projects, tutorials and reviews.